This week we're going to be looking at statics problems, in particular something we call equilibrium. And there are two conditions for equilibrium. The first, we have our two conditions. The first is that the sum of the forces on the system in question is going to be equal to 0. So that's the same thing as saying that there's no acceleration. Now this doesn't mean things aren't moving. They could be moving with a constant velocity, but we have no forces acting. The second condition deals with rotation. It says that the sum of the torques on the object is also 0. And this means that there's no angular acceleration. Now, these are in multiple dimensions, right? You can have forces pushing in the x, y, z directions, and you can have the torques rotating around 3 different axes. But for the most part, we're going to be dealing with planes. So we're going to try to cast our problem so we have forces that are only acting in the plane, and if I have a forces acting on something, that they're going to be acting in the plane and that the rotation is going to be in the plane. And if we do that, then we can usually limit this to just having to deal with x and y and then the rotation axis. So that can simplify things. So our strategy for solving these types of problems is the first thing we're going to do is identify the system. And in particular, we're going to try to identify the object that is having the forces acting on it and having the rotation acting on it. And then we're going to draw a free body diagram that's going to get our forces. And then we're going to use that to figure out the forces and rotation, and then we're going to write down our equations and solve it. And the key here is realizing that for every unknown that we have in this system, we're going to have to find at least one equation to solve for it. So the number of unknowns and the number of equations will be the same. The other thing we should point out is that when we're talking about statics problems, the axis around which something could rotate, might not necessarily be rotating, but it could rotate, is arbitrary. We can choose, since we have no rotation around any axis, if we're going to talk about an axis of rotation, we can choose whatever we want. So we're going to try to choose the axis of rotation such that it simplifies the problem as much as possible.